Hey everyone, it's Justin again. In this lesson, we're going to continue learning about trigonometry, this time with the addition of a graphing calculator. If you have a graphing calculator on hand, pause the video and go grab it now. If you don't have a graphing calculator, you can use the GeoGebra online graphing calculator instead. Let's just jump in so that we can learn how to use these calculators that Mia's showing off. By the end of this lesson, you will be able to use a graphing calculator to find an unknown side length in a triangle using trig functions. First, you'll work through the calculator guide, and then we'll complete two example problems. In this lesson, you will need access to a calculator with trig functions. A graphing calculator is recommended, and since this is the first time in this course where you may be using a graphing calculator, there's an activity to help you get to know your calculator. There are three versions of this activity for the three most common types of calculators you may be using: a TI Inspire, TI-84CE, or the free online GeoGebra graphing calculator. Locate the appropriate activity for your calculator and work through it. Pause the video here and come back when you've finished working through these instructions. Now let's put it into practice. At the beginning of your guided notes for this lesson, there are 6 trig calculations. Pause the video here and do these with your calculator. Now check your answers against the key here. I want to point out these 3 calculations to you. If you think back to our special right triangles, we could calculate these without using a calculator too. I want to look specifically at number 5 together because by hand, we would not get a decimal answer for this. Here's a 45-45-90 triangle. This is our hypotenuse, and from this 45-degree angle, here are the opposite and adjacent sides. That means that the sine of 45 degrees would be 1 over root 2. When we take that square root out of the denominator, our final answer is root 2 over 2. Let's compare that in your calculator. If you calculate the sine of 45 degrees, you get your answer as a decimal. Which of these answers do you think is more accurate for the sine of 45 degrees? The decimal or the fraction with the square root? Root 2 over 2 is more accurate because we don't have to round it at all. I want to point something out here. The exact value of the sine of 45 degrees is irrational, which means that its decimal form actually goes on forever and ever and ever and ever, and well, you get the idea. My calculator shows me 10 decimal places when I put in the sine of 45. Your calculator might show you more decimal places or less depending on your calculator's settings and computing capability, but that will be rounded too. Even this answer, with 64 decimal places, is rounded. No calculator can ever give you an exact decimal equivalent for an irrational number, because there is no exact decimal equivalent for an irrational number. The only way to get an exact answer is to use the special right triangle to find the fraction. As you can see, using a calculator for trig calculations has benefits and drawbacks. The biggest benefit is that it allows you to find trig values for angles that aren't in special right triangles. But the biggest drawback is that most answers are irrational and are not exact. In math, it's important for your answers to be as exact as possible. The solution is to find the trig ratios for 30 degrees, 45 degrees, and 60 degrees by hand, using the special right triangle ratios, since we have the ability to do this without a calculator. Then, for any other angle that we can't do by hand, use your calculator. Now that you know how and when to use a calculator to find trig values, let's see what you can do with this new skill. Our first practice problem says to solve for m in the triangle below and round to the nearest hundredth. We have a right triangle where we've been given one side length and one angle measure. We can use trigonometry to find the length of m by setting up a ratio that uses m. In order to figure out which trig function we should use, we have to know what these sides are. Since the 53-degree angle is the one we want to use, how would you label M and 19 in the triangle using either opposite, adjacent, or hypotenuse? 19 is the hypotenuse because it's across from the right angle. If I am at my 53-degree angle, then M is the opposite side, since it doesn't use the vertex M. Which trig function involves the opposite side and hypotenuse? Sine. Now we can set up an equation that says the sine of 53 degrees is M, the opposite side, over 19, the hypotenuse. Don't reach for your calculator quite yet, though. We don't want to have to round anything until the very end. The best strategy to do this is to solve for M first, and then put that expression into your calculator. Pause the video here and solve for M in this equation. Did you multiply both sides by 19 and get 19 times the sine of 53 degrees equals M? Perfect. This is what you want to put into your calculator all at once before pressing enter to calculate. Pause the video now to enter this into your calculator and get an answer for M. Your calculator should have given you back this number for 19 times the sine of 53 degrees. Remember that even though your calculator has run out of room, this decimal still goes on and on from here. Is this our final answer for M, though? Not quite. Now that we have our answer, we still need to round to the nearest hundredth. So what should our final answer be? If we round this to the hundredths place, we get 15.17 as our final answer. Let's do one more. In our second problem, we're asked to solve for k in the triangle below and round to the nearest hundredth. Notice that this problem looks very similar to the last one. We have a right triangle where we have one known angle, one known side length, and an unknown side length that we want to find. The only difference here will be in which sides you're working with, and therefore which trig function you need to use. From the 27-degree angle that we've been given, how would you label the sides with lengths 11 and k in this triangle? K is the adjacent side, since it's one of the segments that makes up the 27-degree angle. And 11 is the opposite side, since it is the one side that does not use the vertex h. So which trig function do we have that uses the opposite and adjacent sides? That would be the tangent. So, we know we're going to use the tangent of 27 degrees. What would you fill in on the other sides of this equal sign? Since tangent is the opposite side over the adjacent side, this should be 11 over k. Now, before you go to put this in your calculator, we want to solve for k first so that we can put it in our calculation all at once without rounding until the very end. Pause the video here and solve for k. Since k is in the denominator in this equation, we have a little extra work to do. I would start by multiplying both sides by k first to get it out of the denominator, and then divide both sides by the tangent of 27 degrees to isolate k. If you've chosen to solve this equation another way, that's okay too, as long as you also get 11 over the tangent of 27 degrees for k. Now you can go ahead and put this into your calculator to get an answer for k. Check your answer against mine. You should have gotten this long decimal. But is this our final answer? Nope, we still have to round to the hundredths place. What will that give us for our final answer? 21.59. I want to point out why it's so important to wait to put things into your calculator until you solve for your variable first. What if I put the tangent of 27 degrees into my calculator and then rounded from the start? Well, the tangent of 27 degrees rounds to 0.51. If I substitute this into my equation and then solve for k, and then round my answer to the nearest hundredth, I would get a final answer of 21.57 instead of 21.59. That might seem like an incredibly small difference, but these differences can get bigger and bigger as your calculations get more complex, and we always want to be as accurate as possible. This is why we solve for the variable first before putting anything into a calculator. Now you know how to use your calculator to find trig values for any angle measure. Make sure you wait to put anything into your calculator until you've solved for your variable first. Good luck on your practice, and I will see you next time.
Hey.